Have you ever really stopped to think about what a second, or a minute, or an hour actually is? I mean, we live our entire lives by the clock, but the journey to define time with the kind of precision we have today, well, that's one of the greatest stories in human history. So let's dive into this incredible quest to tame time itself. We think of time as this abstract thing, but it's not. It's the invisible engine that drives literally everything. It's the framework for our biology, our society, our whole existence. And get this, in just one single 24-hour spin of the Earth, the sheer density of what happens is just staggering.
In just one day, your heart beats about 100,000 times. It's this relentless personal rhythm that never stops.
And it's not just us. The planet itself gets hit by over 8.5 million lightning strikes, a constant storm of energy, day in and day out.
And every single day, over 350,000 new lives begin. So it really begs the question, right? Who decided to chop up all this density, all this life, into hours, minutes, and seconds? The answer, believe it or not, is literally in your hands.
So check this out. This ancient system is just beautiful in its simplicity. The ancient Sumerians used the 12 knuckles on one hand to count, and then they used the 5 fingers on their other hand to track how many sets of 12 they'd counted. And what's 12 times 5? 60. Because 60 is so easy to divide, it became the foundation for everything. Geometry, geography, and of course time. No calculator required.
Okay, so we've got a way to count, but the next challenge was building a device to do the counting. And the first place humanity looked for a consistent clock was, well, pretty obvious. They looked up. Those early civilizations, they got it. They understood the sun's movement was totally predictable. So from Stonehenge in Europe to the great obelisks of Egypt, they built these massive engines just to track the sun's shadow. They basically turned the entire sky into the face of a clock. Simple, elegant, brilliant. But it had one very obvious problem.
I mean, come on, a clock that only works half the time isn't much of a clock, is it? You can't rely on shadows in the dark or on a cloudy day. This fatal flaw forced inventors to start looking for completely new ways to measure time's passage.
So if you can't rely on the sun, what can you rely on? How about fire and gravity? Inventors created candle clocks that measured time by how much wax burned away, and of course, hourglasses that used the consistent fall of sand. These were really clever solutions for telling time in the dark or even on a moving ship. But here we go again. Our next fatal flaw. These clocks were consumable. You had to constantly light a new candle or flip the hourglass. Timekeeping was a manual, finite process. The hunt was on for a clock that could just run itself. And that's where we get the next leap forward, the clepsydra, or water thief. Now here's the genius part. Instead of measuring water dripping out, which slows down as the pressure drops, this genius Chrysippus of Alexandria measured a constant flow of water coming in. This raised a float at a perfectly steady rate, creating a continuous automated clock. An amazing invention, right? But still, not perfect. The final flaw of these elemental clocks was super subtle, viscosity. See, water flows differently depending on its temperature. A water clock in the winter would literally run slower than one in the summer. For true precision, humanity had to move beyond the natural world. And that brings us to the mechanical awakening. This is the moment we leave behind that gentle flow of water and embrace the sharp, precise, and predictable tick of a machine. And what drove this revolution? You might be surprised. It wasn't commerce or science. It was prayer. Monks in the Middle Ages needed to know the exact times for their daily prayers. And this religious need for precision led Pope Sylvester II to build the first recorded mechanical clock way back in 996 AD, using weights and gears to mark time. This mechanical approach just kicked off an absolute race for accuracy. Early watches in the 1500s were terrible, losing up to 15 minutes a day. But then came the game changer, the pendulum. In 1656, Christian Huygens' pendulum clock took that drift from many minutes all the way down to mere seconds. That was a monumental leap in precision. But even the pendulum had its weakness. Its precision relies on the constant pull of gravity in a perfectly stable swing. Now, that's great for a clock in a town hall, but completely useless on a rocking ship or in your pocket. The need for portable, personal time demanded a new kind of engine.
So we leave the world of grinding gears, and we enter the invisible world of vibrations. The solution to portable time wasn't bigger gears or better springs. It was something almost magical, hidden inside a rock.
Okay, this is where it gets really cool. It's a principle called piezoelectricity. When you pass a small electric current through a tiny, tuning fork-shaped piece of quartz crystal,
It vibrates. And not just randomly. It vibrates at an incredibly stable and consistent frequency that never, ever changes. No friction, no wear and tear, just a perfect, reliable pulse.
And that pulse is exactly 32,768 times per second. A microchip inside the watch just counts these vibrations, and every time it hits that magic number, it tells the second hand to move forward one tick. This is the technology that powers pretty much every watch you see today.
But even a crystal isn't perfect enough for things like GPS or global communication. For that, we needed to find a beat that was woven into the very fabric of the universe itself, a pulse that would be the same here, on Mars, or in another galaxy.
For the ultimate standard, we looked inside the atom. Our modern definition of exactly 1 second is now tied to the natural, unvarying energy transitions of a cesium-133 atom. It is a fundamental constant of nature, and it will never, ever change.
And how many times does it oscillate in 1 second? Over 9 billion times. 9,192,631,770 times. That mind-boggling precision is what allows your GPS to work. Without it, your location would drift by kilometers every single day.
And that brings us to today. The journey has taken us from estimating time by the length of a shadow, to measuring its flow with water, to capturing it with the mechanics of gears, to feeling its pulse in a vibrating crystal, and finally, to defining it by the oscillation of a single atom.
It's an incredible story of human ingenuity. We've gone from being ruled by the sun to defining the second with a precision that can measure the warping of space-time itself. Time is the one thing we can never stop, but we have learned how to watch it pass. And so the final question is, now that we have this power, what will we do